Hello friends, welcome to the next session. In this session, we will be discussing quicksort using C. While in previous section, we have discussed about the basic technique, how we do quicksort. So if we move on to this lecture, we should see the detailed lecture that is quicksort part 1, my just previous lecture. So let me give the recap of the story, what we were doing, and then continue to the coding using quicksort here. Okay, so first of all, if you want to make any query, you can go on to satyavanteacher@gmail.com and you can make any query. So let us proceed. In the last time we have discussed about that quicksort is a divide and conquer kind of policy, and in this algorithm what we basically do is we find a pivot element that divide the list into two parts. We separately sort the left part of the list and we separately sort the right part of the list, as I have shown in this very presentation. So what we found is the first element was chosen to be the pivot element, and then this element was fixed at its position in the list, that is here, and all elements were which were on the left side are smaller than this pivot element. All elements which are greater than are at the right side, and then the complete array is divided into two parts. First partition is containing smaller elements and the second partition is containing the larger elements. So these two lists again will be considered as different lists and will be sorted differently by choosing pivot from these lists. Okay, and this is what we were doing while splitting of arrays. So we have chosen here two anchors. This is what named is P, this is what I have named Q in the program, and this is my basically the lower element, that is the pivot element. So we will keep on increasing on the right side until unless we find the element that is greater than this pivot element. We will mark onto this, and from this side we will keep on increasing on the left side until unless we find the element that is less than this pivot element. Okay, and then you can see here that 13 is greater than 11 and 3 is smaller than 11, so we will interchange these two, and the next step we will be getting these two interchanged, and we'll keep on doing the same until these P and Q cross each other. P and Q cross each other, we will keep on doing this, and finally when Q has been at crossed position, this will be interchanged. Element at Q anchor will be interchanged with the pivot element, and this will finalize the splitting of an array. So basically what we are going to do here in the algorithm is I will show you how to split the array and how to then quicksort them. Okay, how to split the array and how to quicksort them. These two separate lists are ready, and the same algorithm will be implemented to these, and I will keep on splitting them until unless my number of array in the list are left with the one array. Okay, one element. So let us proceed to the code. Here we go. With a quicksort, first of all I have taken here array of 10 elements that will be containing the same element I have given in the example, and then I have displayed them. One algorithm is called, that is quicksort, and then after calling quicksort, we have displayed them again. Now this quicksort will work in the way that I am showing you here, like this way. Before showing the functionality of quicksort, I will run it for you so that we will be able to see what will be the answer here. Okay, this will be the answer. Array before sorting is this list. You can see here 11 to 9, 13, 57 and the random list. Array after sorting is containing the sorted elements 1, 2, 3, 9, 11. So let us go to the details of the program. First of all, what we'll do is the main will display array, then I will go to the quicksort. Quicksort will do these things for me. In quicksort method, I have passed the complete array and upper and lower limits of the array. Means if array is containing 10 elements, then lower will be containing 0 and upper will be containing 9. As I've shown here, you can see that while calling quicksort first time, it is containing 0 and 9. Okay, then if upper is greater than lower, means if there is at least one element in the list, then what we will be doing, we will first split the array into two parts and then two parts will be individually sorted. Okay, then this list will be individually sorted and we can see the same, that splitting is taking place. How splitting is taking place? This is what algorithm is saying, that split the list into two parts and then quicksort them individually. Now what split method is returning? After splitting, we need to get index of the pivot element that we were selecting. If you remember that in the PPT, what we did is we have finalized the position of 11 and then 11 is the middle element, but wherever it is occurring, it may or may not be middle element because there is 4 element on the left side and 5 element on the right side. 11 is the element whose position is to be returned by the split method, because on the basis of this only we will be making next quicksort calling. So from 0 to 3, 0, 1, 2, 3 will be calling first quicksort function, and from 5 to 9, 5, 6, 7 and 9 will be calling second quicksort method. Okay, you can see here that A, lower and upper are sent to the split method, and here A, lower I minus 1. I is what? This position of pivot element. So from 0 to I minus 1, and then from I plus 1 to upper will be calling the second one, right? So let us watch what split method is doing for me. F7. Well, we'll need to do this split call. All the list is sent to the split method, and here will be storing A lower, means the pivot element is stored into the I variable, and lower plus 1, that anchor is settled, the red anchor into the presentation. You can see upper is stored in Q, the blue anchor you can see in the presentation. If I show you in the presentation, that there we marked with the two anchors, this is what P is containing and this is what Q is containing. P is containing the value 1 and Q is containing the value 9, or we can say P is containing the value lower plus 1 or Q is containing the value upper. So in algorithm we have done the same. While Q is greater than or equal to P, while Q is greater than or equal to P. Means the anchors have crossed each other. Before anchor cross each other, we need to follow these following steps. What we do here is, until unless we find the greater element, we keep on proceeding to the right. We can see here again that until unless we find greater element, we keep on proceeding on right side. Until unless we find the smaller element, we keep on proceeding on the left side. We can see here, but here 13 is found to be greater and 3 itself is found to be smaller element, then these will be swapped. Let us make or move to code again, that until unless we find greater element, we keep on proceeding on right side. P is done plus plus. Until unless we find the smaller element, we keep on proceeding on the left side. But in example 3 itself is the smaller element. So if P is lesser than Q, then we keep on swapping. We do the swap. Then this method is again called. This loop will be again called for the second iteration, for the third iteration, until unless we do all the swaps for us. You can see here in the list, first we swap 13 and 3, then we swap 57 and 1, then we go on to the last step, that is 25 and 1, but 25 and 1 is not swapped. You can see here 25 and 1 is not swapped. Why they are not swapped? Because P now has been crossed by the Q. So what will be swapped now? This pivot element will be swapped with a value that is marked by, that is pointed by the Q. You can see here that the pivot element is now swapped with the value that Q is pointing. So okay, let us go to the algorithm. At last we are swapping the value that is Q containing, Q is pointing with the pivot element. Okay, this part of my programming is doing the same, swapping the pivot with the element at blue anchor in PPT. Okay, then finally wherever my Q is, I return the position. Q is where? Q is pointing actually to the 11, the pivot element. Q is pointing to the pivot element, so here we return the pivot element in the split method. Okay, so let's make our move here, and if it is returning I, so I is position of the pivot element. So in quicksort, what we do here, A lower to I minus 1 means one position less than the pivot element. Okay, I am passing to the quicksort, next quicksort. So this method will call itself again quicksort, and here will be giving the array and 0 and 3. So this process will keep on repeating until unless upper is greater than lower. If this limit will be occurring, means there is only one element in the list. At that point of time, this will stop calling itself and array will be finally sorted. So this is all about how we do quicksort in C language. For any kind of query, you can ask me at satyavanteacher@gmail.com. So if you like my video, subscribe my channel, and you can comment under this video if you have any kind of query, or you can mail me if you have any kind of query. Further discussion on this quicksort can be done, for example randomized quicksort, and how to choose pivot. Let us have some discussion within 2-3 minutes. So here all the matter that make quicksort a valuable sort is pivot selection, that is this element selection. this is not all the time taken, pivot is not all the time taken to be the left one. Suppose my list is something like 1 1 1 2 2 2 3 3 3 4 4 4, and then finally there is element 5. Okay, then if I choose 1, so we need to make we need to split. When we'll be splitting the elements, then it is very hard for me to make the algorithm valuable, because when pivot will be selected to be the first element, it will be worth no importance if element are already almost sorted. So pivot selection is a greater concern. For this we need to do a randomized quicksort. So what you need to discuss about pivot selection, you can mail me or you can comment here in the comments under the video. Thank you very much for watching. See you in the next tutorial. Thank you.